So today we're going to be looking at measures of variation. Now, yesterday, what we ended up looking at, or last time, is measures of central tendency. In other words, mean, median, mode, and range. Now, those are well and good for measuring on how well a data goes around various points. But if we need to talk about the spread of data or how to compare data, we need measures of variation or how those values vary. Our first vocab word, is standard deviation. Standard deviation is a measure of the dispersion or spread of a set of data. Now you're going to see, if we're talking about a sample, we're going to use this S. And if we use the population, we're using this Greek letter, it looks like a cursive O, called sigma. Your calculator will actually tell you this value, and your calculator is going to look like capital S, X. All of those deal with standard deviation. The second word is variance. So variance is the average of the squared differences from the mean, or on how much do these vary. And if you notice, the sample variance is just our S squared, or our standard deviation squared. But for the population, it's our sigma squared. Your calculator will not actually find this value for you, so what you're going to need to do is take your standard deviation and square it. Now, like I said, your calculator will actually do these steps for you. So you're going to hit Stat, then Enter. You're going to move up, hit Clear, move down. Once again, that clears out any data that you have in that list. Then you're going to hit enter the data, hit Enter after each number. Second mode to quit out. You go to Stat, Over, hit Enter. And then you're going to go down to Calculate, hit Enter. All of these were the same steps that we did last time for mean, median, mode, range. But this time you're going to notice the SX, which is standard deviation. So that's an additional number that we're going to look at. I'll talk about this now, but we're going to deal with the coefficient of variation and exactly what that is in a little bit. But for this, we need our X bar, or our mean, and we need our SX, which is our standard deviation. And to find our coefficient of variation, shortened to CV, we're going to take our standard deviation divided by our mean. Once again, I'll look at that in a little bit. So example 1. Example 1 is going to have us find Big Blossom Greenhouses was commissioned to develop an extra large rose for the Rose Bowl parade. A random sample of blossoms from hybrid A bushes yielded the following diameters in inches for mature peak blossoms. So we have our numbers. So what we're going to do in our calculator, we're going to once again hit Stat, hit Enter, move up, Clear, down, and then enter these numbers. So 2, Enter, 3, Enter, 3, Enter, 8, Enter, 10, and 10. Then it says second mode to quit out. Hit Stat, move over, hit Enter. We're going to go down to Calculate and hit Enter. And if we notice, listed right here, it says SX equals 3.74. So that tells us our standard deviation, Our S is 3.74. To find our standard variance, we're actually going to do 3.74 squared to get 13.99. Okay. On back. Coefficient of variation. A disadvantage of the standard deviation as a comparative measure of variation is that it depends on the units of measurement. This means that it is difficult to use the standard deviation to compare measurements from different populations. For this reason, statisticians have defined the coefficient of variation, which expresses the standard deviation as a percentage of the sample or population mean. So, in example 2, we have parts A, B, C, D, and E. For A, B, and C, we're going to find mean, median, mode, range, sample deviation, and sample variance. So, your calculator will do the vast majority of this for you. So, okay. So once again, we're going to hit stat, hit enter. We're going to move up, clear, move down, and then we're going to type in these numbers. So 4, 4, 6, 5, 3, 7, 9, 2, 4, 3. Second mode to clear out. Stat, move over, enter, and then calculate. So remember, X bar means mean. So our X bar is 4.7. Our median, well, actually, the next thing that I see listed is XX, which is our standard deviation, or our just plain S, which is 2.11. Scrolling down, I see my median is 4. Range, biggest minus smallest, or our max number minus our minimum number. So 9 minus 2 is 7. Mode, looking at our list of numbers, the number that appears the most is 4. And then to find our standard variance, we're going to hit clear and type 2.11 squared, or our standard deviation squared, and get 4.45. So go ahead, pause the video, do the same process for parts B and C. After looking at parts B and C, check your answers. Our next question wants us to find the coefficient of variation. So as a reminder, coefficient of variation, it said, pull it up. Coefficient of variation is our standard deviation divided by our mean. So for problem A, it is our standard deviation, to 0.11 divided by our mean, 4.7, and we get 0.449. Okay. Go ahead and do the same thing for problems B and C. For both of those problems, you should get problem B, 0.443, problem C, ended up being about 0.4799, somewhere around there. So rounding it to 0.480. And then you're going to have a question of which problem set of data is closest to its mean. In other words, we want our coefficient of variation to be as small as possible. So the problem that has the smallest coefficient of variation is problem B.